Hello everyone, I am Kshama Kulkarni again from Computer Science Department, MIT, Aurangabad, Bama University. In our last video, we have seen the basics of data structures and in that linear data types. In our video, we are going to cover non-linear data types. So let us have a look. So the learning objectives are: what is data structure? Non-linear data structures. So let us revise the data structures concept. The collection of data are frequently organized into a hierarchy of fields, records and files. Suppose example, mobile number, name and city can be individually called as a data, and if we collectively called as information. So to process the information by using some structure is called as a data structure. So let us refine it. Data structure is a specified format for organizing and storing so that it can be accessed and worked within appropriate ways to make a program more efficient. So we have already seen the types of data structures. One is linear data structure and second is non-linear data structures. We have seen the definitions of it also. The linear and non-linear data structures means, linear means in the form of list. A linear data structure travels the data element sequentially in which only one data element can be directly reached. And what is non-linear means? Items are not arranged in sequential order. Every data item is attached to several other data items in a way so that it is specific for reflective relationships. So let us move on the basic. Non-linear data structures. What are non-linear data structures? Trees and graph. So let us see the concept one by one. The nature view of a tree: branches, leaves and root. But in our computer science language, we can represent a tree in the form of root, branches and leaves in the reverse order. And the leaves may be called as nodes. Why we are treating as a tree? Tree is used to represent a hierarchical format. So let us define it by an example. Suppose MIT Aurangabad has mainly two departments, engineering department and BTech department. BTech department and engineering department have again several branches as CSE department, electronics department and so on. And likewise with BTech, mechanical, electrical, computers and so on. So likewise we can represent our hierarchy of data in the form of a tree. So we are using it. So let us have a definition of a tree. A collection of entities called as nodes and represent in a hierarchical format. So these circles are particularly called as nodes and the lines connecting these circles or nodes is called as a edge. So what are the relations of a tree? The topmost node is called as a root. The root followed by the nodes are called as children, and again the nodes followed by the children are called as the children's of the parents' nodes. So the middle nodes are called as the parents. Siblings have the same parents. If a node have multiple nodes followed by that root node, then that is called as siblings. And leaf that has no child. So let us have an example of it. So I have taken one example, numbered 1, 2, 3 and so on are the nodes. And suppose 1 have the following two nodes, 2 and 3. 1 will be called as a root and 2 and 3 will be called as a child. And again it is following by some nodes. Then these are called as the parent nodes. 2 and 3 will be called as a parent node, and 4 and 5 likewise 6 and 7 will be called as a siblings of 2 and 3 respectively. Again 4, 5, 6 and 7 have not further classified again. So these are called as a leaf nodes. No extension further. That's why it is called as a leaf node. So what are the concepts like ages, depth and height? Ages means if a tree has n nodes. In our example, if we are considering number 1, 2 and 3 nodes, then there are 3 nodes, n equals to 3. It will have n minus 1 edges. N minus 1 means 3 minus 1 edges. Edges will be 2. Likewise, we can define depth and height. What is depth? Length of a part from root to x, that is the last node, and height of the x, number of edges in the longest path from x to leaf. What are the applications of tree? Sorting natural hierarchical data, for example, file system. Second is organized data for quick search, insertion, deletion, that may be come in the part of binary search. Third is dictionary, and not the least, network routing algorithms. These are the applications of tree. Let us move on. Binary tree. What is binary tree means? Each node can have at most 2 children. A node has only a leaf left child and a right child. A leaf node has no left or right child. Let us have an example of binary tree. So this is a root node. 1 number is a root node. 2 is called as a left node of a root, and 3 is called as a right node of a root. We can see that every root has 2 nodes or node. Okay, so 5 is extending either left and right node, and 6 is having only a node. 7 is having a node extension, so it is called as a leaf node and having a null value. What is strict binary tree? Each node can have 2 or 0 childs. Means in binary tree there is possibility of having only 1 node, but in strict binary tree there is no possibility of having only 1 node. We can represent likewise as there are only nodes having either 2 nodes or no node. So let us move on the next concept as graph. Vertices. Now the nodes are called as vertices and these lines are called as edges. So let us define the graph. A data structure that consists of a set of nodes, vertices and a set of edges that relate to nodes with each other. A set of edges describes the relationship among the vertices. A graph G is defined as follows. G equals to V, comma, E. So V is vertex and E is edges. Let us have an example of graph. V equals to 0, 1, 2, 3 and 4. Means these are the vertices 0, 1, 2, 3 and 4. And the edges can be defined as the line moving from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and it may be from 2 to 2 itself. So we can define as 0 to 1. It is directed from 0 to 1. So represented as 0 to 1. 1 to 2. Directing from 1 to 2. So it is represented as 1 to 2. 3 to 4. 4 to 3. There are 2 lines from 4 to 3 also and 3 to 4 also. Okay. So likewise we have an example of graph. Graph can be further defined as directed graph and undirected graph, weighted graph. What is meant by directed graph? In this example, we have specified a directed graph. 0 to 1 given by a direction. So, whenever there is a specified direction, it is called as a directed graph. When directions are not specified, it is called as undirected graph. And weighted means some weight is assigned. The distance weight is assigned at some time, then it is called as a weighted graph. Thank you.